Hello friends, welcome to our channel. In this lecture, I would like to explain another example based on the losses of prestresses in the prestressed concrete. So in the previous lecture, I explained very clearly some of the example based on the introduction unit. So here I will start the another chapter, that is losses of pressures in the prestressed concrete. So here there will be so many losses. So we will solve some more examples after this example. Then we will get some clear idea. So how many losses will be there on the loss of prestressed. So see the question. A pretension beam 250 mm wide and 360 mm deep is prestressed by 10 wires of 8 mm diameter. So it is always better, along with the question, you have to write down the given data and draw the diagram accordingly. So the beam size will be given 250 mm wide and depth will be given 360 mm height. Okay. So if you see the diagram, how it will be, it will be like this. So it will be 250 mm and the depth will be 360 mm. Clear? Then what is given is prestressed by 10 wires of 8 mm diameter. So area will be given. What is the formula? N into pi d square by 4. That is total N will be number of wires. Sorry, that is 10 into pi, diameter will be 8 square by 4. If you simplify by using your calculators, you will get around 502.65. Area will be in terms of mm square. Here, what is given? Initially stressed to 1000 Newton per mm square. So I will denote that one with the stress will be sigma and initial will be 0 Ri. So according to your convenience, take down 1000 Newton per mm square. So the centroid of the steel wires is located at 105 mm from the soffit of the beam. So first see the overall depth of the beam. So where the centroid will be located here at 180 mm from top and 180 mm from bottom. So means exactly the centroid axis will be located at center for the rectangular section. Similarly, symmetrical I section also it will be center only. Unsymmetrical I section and T section will be different. The centroidal position will be calculated by using the formula A1 Y1 plus A2 Y2 divided by A1 plus A2 like that. But for rectangle, circle and symmetrical I sections, exactly the centroidal axis will be located at the center only. So exactly 180 from the top and 180 from the bottom. And what is given here? The centroid of the steel wires. Steel wires means the tendons. The centroid of the steel wires is located 180, 105 mm from the soffit of the beam. Soffit means bottom of the beam. Okay, soffit means this bottom of the beam. From here, it will be located at how much distance? They are given 105 mm. So from here, from the center to the top, the remaining position will be the eccentricity. So how much it will be? 180 minus 105 will be equal to 75 mm. So this is how the eccentricity will be given according to the condition. Sometimes they will be given directly in the question. Eccentricity will be located at 75 mm from the centroidal axis. But here they will given indirectly 105 mm from the soffit of the beam means the tendon will be center to the soffit. It will be 105 mm distance and the remaining distance will be 75 mm. Okay. If you know, if you take that the beam full view like elevation, the centroidal axis will be this one and the tendons will be placed exactly here like this. Okay, this is how it will be appear. It is better to draw the diagram for your convenient. Then What is given? Determine the maximum stress in concrete immediately after transfer, allowing elastic shortening of concrete only at the level of the centroid of steel. So first we can find the stress in concrete. Like in the general formula, how we will find stress in the concrete? So we have one standard formula, that is P by A plus or minus PE by Z. Okay, then after that we find out the elastic loss shortening considering the transfer of the concrete. However, the concrete is subjected to additional shortening due to creep and shrinkage, and the steel is subjected to a relaxation of 5%. Find the percentage loss of stress in the steel wires. So first you can find out the stress in the concrete. After that consider the elastic shortening in the concrete. Then again additional shortening due to creep, shrinkage, and relaxation. You have to consider all these three, including this four losses of the concrete. So the standard data will be given. ES will be 210 kilonewton per mm square. EC will be, so elasticity of steel will be 210. Concrete will be 36.85 kilonewton per mm square. Creep coefficient 5 will be given 1.60. Residual shrinkage strain will be given 3 into 10 to the power of minus 4. See here, first step what we have to do. First, it is always best to find the area. Okay. After obtaining the given data, it is best to find the area of the beam. So 250 by 360. Okay. So how much you will get? Simplify that one. You will get 9 into 10 to the power of 4. Area will be in terms of mm square. So remaining things for rectangular section, the moment of inertia, what is the formula? I equal to BD cube by 12. So what is B? 250. What is D? 360 cube divided by 12. If you simplify, how much you will get? 9.72 into 10 to the power of 8 mm power. So you will know moment of inertia always it will be mm power 4 only. Then what you have to find? Next step, already we find area and stress in the concrete at the level of steel. Stress in concrete at the level of steel. So what is the formula? That one will be equal to P by A plus PE by I square. So generally we have one standard formula. So whenever a tendon is placed along the centroidal axis, the formula will be P by A plus or minus M by Z. So one more formula, whenever a tendon is placed at some eccentricity, we will get some another formula, that is P by A plus or minus or plus PE by Z plus or minus M by Z. So here the same formula it will be. So how we will get this PE by I, you know, this ZD will be equal to I by Y. Y here it is the distance of the centroidal axis, maximum distance for the centroidal axis. But here you will get in terms of eccentricity. So that will be equal to E here. So that is P E square by I. If you substitute here in terms of Z equal to I by Y, I into E square. Like that you will get directly the formula will be P by A plus P square by I. You please remember this formula. So after that, how this P will be obtained? P is the pre-stressing force. So that one will be equal to stress into area. So what is stress will be given in the question? 1000 Newton per mm square. Area will be, so already we found that one. That one will be equal to 502.65 mm square. So this is the value here. 502.65 65 mm square. If you simplify, that one will be equal to 502 into 1000, 655. In terms of newtons, you will get directly. Okay. Then after that, substitute in the formula. Stress in concrete 502 655, and area will be which is equal to d by d, which is 9 into 10 to the power of 4, and this one will be plus 502 655. This one will be eccentricity will be 75 square, and moment of inertia bd cube by 12 will be equal to this value 9.72 into 10 to the power of 8. So please simplify this value separately in the calculator. That one will be, you will get around 5.59, and again this value separately, that one will be equal to 2.91. So finally you will get 8.50 Newton per mm square. So what is our next condition in the question? So once we find out the stress in the concrete, again they will ask immediately after transfer, allowing elastic shortening only at the level of the centroid of the steel. See here, loss of stress, find out the loss of stress due to elastic shortening of the concrete. So the formula will be delta Fc equal to loss of stress due to elastic shortening of concrete. So you please remember this formula into stress value. So this is the stress in concrete. Okay, M into sigma. That one will be equal to how much? This M will be equal to modular ratio. M equal to, how it will find in the question only, they will given the data ES and EC value. So modular ratio, you please remember this formula, M equal to ES by EC directly. So modular ratio will be given 210 kilonewton per mm square, 210 into 210 kilonewton per mm square, and this one will be 36.85 kilonewton per mm square. Okay, so if you simplify, you will get this modular ratio into in terms of mm, that is 5.70. So please substitute in place of m value 5.70, and this stress in concrete will be equal to how much? 8.50. So if you simplify around, you will get 48.45 Newton per mm square. Okay, then what is the original stress in the wires? So initially the stress in the wires will be 1000 Newton per mm square. So what is the loss obtained here? 48.45 Newton per mm square. So after that, the original stress in wires will be equal to, so how much it will be? 1000 minus 48.45. So what is the value here? That is 951.55 Newton per mm square. So this is the stress in the wires after elastic shortening of concrete happens. Okay. So after obtaining stress in the wires, again calculate actual stress in concrete at the level of steel after obtaining this elastic shortening of concrete loss. Okay, that is actual stress. So the formula will be P by A plus P square by A. So what about this P value? P equal to stress into area. So how much the stress will be obtained after loss? 951.55. Again, the area of the steel waves will be 502.65 mm square. So how much you will get if you simplify? That is 478296. So calculation is very important. Here it is not possible for me to show how to calculate by using calculator here. So it is best to calculate by your own. Then you will get the same value. Okay. So the original prestressing force after loss obtained will be this much. So please substitute in the above formula. So you will get actual stress will be equal to 478296.6 by area will be 9 into 10 to the power of 4 plus P square by 8, 478296.6 into E square, that is 75 square, by I value. What is I value? 9.72 into 10 to the power of 8. So after simplifying, again how much it will be get? So this one will be 5.31 plus this one will be 2.77. So the total value will be equal to 8.08 Newton per mm square. So this is the way how to find out the actual stress after obtaining the elastic shortening of concrete. Then the various losses that occurs. So we will get the pre-stressing force value and remaining values also. So first one is loss of stress. According to the question, what they are asking, loss of stress due to elastic shortening. That one will be equal to, we know before only we calculated. That is how much? See in this page, 48.45 Newton per mm square. That is the same loss only. 48.45 Newton per mm square. And the second loss is loss of stress due to creep of concrete. Okay, creep of concrete. So here it is very important to remember the formulas. So the creep of concrete will be equal to 5 MFC. So what is phi? The creep coefficient which is given in the question, that is 1.60. And what is M? Modular ratio, M equal to ES by EC. So already we calculated that one. If you see here, you will get a clear idea. That is 5.70 M equal to, clear, 5.70. Again, what is this FC value? FC will be equal to 8.08. So what is this one? Actual stress. This FC will be equal to, see here, this one, this actual stress value. So you please remember this FC will be equal to actual stress. Once you simplify, how much you will get? That is 73.69 Newton per mm square. Again, go to the third loss. Loss of stress due to shrinkage of concrete. Loss of stress due to shrinkage of concrete. So what is the formula? EHS into, yes, that is the formula for the loss of stress due to shrinkage of concrete. So already if you go and observe in the question, what is given? EHS will be residual shrinkage strength. So that one will be this one, EHS. Into ES value will be given 210. So just substitute, you will get that answer. That is 3 into 10 to the power of minus 4 into 210. How much you will get if you substitute, simplify? You will get around, so here 210 into 10 to the power of How much will be given in the question? 10 to the power of 5. So kilonewton to Newton, you please substitute 10 to the power of 3. So how much you will get? Around you will get 63.00 Newton per mm square. So this one will be in terms of mm square. And again, what is the fourth loss? Loss of stress due to, relaxation loss. So how much relaxation loss will be given? You please take the example relaxation loss of 5%. Okay, 5 in terms of percent. Percent in the sense 5 divided by 100. 5% of the initial stress. Relaxation loss will be given. That is 5% of the initial stress. Okay, that is 1000. So if you take, you will get around the loss will be 50.50 Newton per mm square. Then take down all the total losses. So what are the total losses? 48.45 plus this 73.69 plus, and again this 63 plus, and again this 50. So the total, how much you will get? 235.14. Maybe you will get some digits different like 234 or 236. So no problem. Okay. So the total losses will be taken around 235.14. So here, what originally the given initial stress will be? The initial stress will be 1000. After considering all the losses, after obtaining all the losses, the total losses, one due to the elastic shortening of concrete, another due to the relaxation, another due to the creep, another due to the, okay, this four, shrinkage of the concrete. So after obtaining all the losses, the total losses will be 235.14. So if you want to know in terms of the percentage loss, how much? So we know the obtained loss will be 235.14, and original total stress initial original initial stress will be given 1000 into 100. So almost we know that will be get 23.514 percentage. So this is the percentage loss after obtaining all the, considering all the losses in the pre-stress. So that is 23.514. This is the way how to solve the problem according to the condition. So this is the first example in this chapter, that is losses of pre-stress. If you solve some more examples repeatedly, so you will get some clear understanding how the formulas will be clearly remember and how the formulas will be easily applicable according to the given data.